Okay, welcome everybody to our first Wednesday. I get to do two introductions here. So the first introduction is for Dr. Stephanie Ware, who's not here for medical reasons, but she really wanted to be here. And Steph is a lot of great scientists around, but that's one thing. It's another thing to have huge impact. And Steph has had a huge impact in marine conservation. She established, and with others, nobody does anything alone, the Reef Resilience Network, which has over 75 countries and reef managers from those countries learning how to manage reefs in a time of climate change and acidification and coral bleaching. And then after that, she went back to school, got her PhD, and did her PhD, she discovered what you're going to be hearing about, so I don't want to steal the punchline. But her PhD sort of set her on the path for this Ocean Sewage Alliance, which the Aquarium is part of. Brian, who I'll introduce in a second, is part of, a lot of institutions are part of. So that's Steph, and she's a new director at the Aquarium. Now, the other person I get to introduce is Dr. Brian Silliman, Steph's husband. He's the Rachel Carson Professor at Duke. He's, in my mind, one of the top 2 or 3 marine ecologists in the world, literally. But that's not his greatest accomplishment by any means. I mean, he's written 100 papers and so forth, but his biggest impact was he got Steph to become a major in environmental science that set her off on her career. And they were there at UVA. At UVA, it's a beautiful campus out in the lawn. Brian's manning a table with HIV awareness. I don't know what Steph's table was. And they started talking to each other. And Brian could be pretty charismatic and compelling. Steph changed her major as a result of that. She also gave Brian her telephone number. He lost it. I think he lost it about 2 or 3 times. She was smitten with him, but then she got pretty annoyed. Eventually, they got together, and I have to tell this because it's very fitting. It's at an aquarium. Eventually, they got together. This was Brian's line, literally, and was, "Will you come see my fish tank?" And that's how they got together, and all the rest is history. And this Ocean Sewage Alliance is a really important thing. So Brian's going to tell you about it. And Steph is watching. Don't screw up.
Well, thank you for this opportunity to pitch it. And thank you, Peter, Adina, and Stephanie, and Claire for putting together this opportunity, both in the talk and the time here. I've really enjoyed our dinner tonight, and I look forward to more interactions. This is a topic that I'm very passionate and excited about to present to you, even though it's not my dissertation. I'm passionate about it because it's completely changing the way I'm going to be doing research over the next 10 years, because it's such a serious threat that it challenges and threatens my life's work in many ways. Working with marine ecosystems, trying to save them using typical protected areas. What this research has shown to me is that they're under threat from sewage pollution. I didn't even realize it. And it's at a large scale. And why am I excited about it? Is because Stephanie, in her usual manner, has seen a threat, and what she says, let's find a solution. And she's brought together a huge community, very diverse community, to think about this problem, to talk about this problem, and to innovate on this problem. So I'm going to talk to you about that today. So it's an interesting talk, and Stephanie wanted to make it more fun, and she said we're going to integrate games and a bedtime story. And I know you're good at both, Brian, so you can do this just fine. Okay, so the game, the way this is going to work, if you can take out your phone, so it's okay to have the phones out during the whole talk. You can either take a picture of this, and it'll take you to the website, or you can actually go to menti.com and enter in this code right here. And the game that we're going to play is a game that many of you are probably familiar with, 2 truths and a lie. And what will happen is that you will get 3 statements that come up, and you choose the lie. And then we'll record everybody's answers, and we'll show the results. Just to practice, though, what we're going to do is if you go to the website, this isn't 2 truths and a lie. I want you to pick the truth that most likely describes you right now. Are you an early bird, a night owl, or are you a permanently exhausted pigeon? So if you can go to the website and vote, we'll see how that goes. And it should start to accumulate. Look at this. It's instantaneous. Look at this.
You got to go back to the QR code. More time on the
You need more time on the QR code. Sorry about that. Okay, sorry about that. Give you more time. See how that works. We had more success with quick success, menti.com. If you go there and just put in those 8. Try that. And I guess we'll do this like a lecture hall. Does anybody need more time? Good? Okay, good. All right, I'll go on to the next one. So you know that question. You can, okay, we're adding. Look, we're all permanently exhausted pigeons, and we do have some night owls. Okay, so I understand if people doze off a little bit, but I can see that we all need to take care of ourselves and make sure that we're okay, especially during this time. So we got how we can play the game, and it's still accumulating. Okay, good. Everything's working well. So now let's go into the bedtime story. And it starts like many do. It starts off once upon a time. So once upon a time, humans, we were living in balance with nature. Do you remember that? Probably not, because it was a long, long time ago. And back then, we lived and ate and we slept and we pooped and we peed as a natural process. And in fact, many small communities would use human excrement as a fertilization for the gardens to improve food source and food quality in that environment. Human excrement, it was like the ultimate recycling machine there. And indeed, human excrement was a part of the green cycle in that way, and we as humans were just another species not fouling our nest in that environment. And then we began to grow in numbers, and we became civilized. And that complicated things a little bit. We increased in numbers, we multiplied, and that multiplication magnified the organic material that we were producing in that environment. And lo and behold, over a relatively short period of time, that resource became a waste. And the transition, anthropologists have studied this for a while, the transition of some component in human society, it transitions from a resource to a waste, has been noticed in a lot of cases. And Philip Havlicek said something that was pretty insightful. He said, the issue of waste in human society is primarily an issue of the attitudes that people have towards waste. Whether or not an object becomes waste depends on the attitude we have towards it. I guess in other words, in very simple words, one person's trash is another person's treasure. So what is it, the treasure I'm talking about here? The treasure I'm talking about in this talk is poop. That's right, I'm going to be talking about poop and pee. And I know a lot of people don't like to talk about poop and pee. In fact, in a lot of circles, it's rude, it's impolite, and it can be offensive. In fact, a lot of people who are in the audience might feel a little uncomfortable talking about it. Yet we all do it. A lot of us pretend we don't. And we celebrate it when the toddlers in our lives learn how to do it right. That is, it just disappears. It goes away magically. But what does away really mean? Well, away doesn't necessarily mean that it's gone forever. Away typically means that it's gone into the environment. And when it goes in the environment, more often than not, the endpoint that it's going to is going to be going to the ocean. And we see that here. The pipes, in fact, in the waste management systems are designed to take all that waste product away, the poop and the pee, to take it through those pipe systems and dump it in the ocean. And there are pipes like this all over the United States and all over the world. And that concentrates ocean pollution, sewage pollution in the ocean. And hence the title, Ocean Sewage Pollution. So we're going to learn about that in the next couple slides, and we're going to do that game to help us learn about the facts, about the extent of this problem. So here's the first quiz question, right there. I'm going to hit enter, And then we will get a little circle that goes. Okay, it's working. Excited about this. And then you will see 3 choices. Here they are. They should be up on your phone. And you want to pick the lie. It's 30 seconds. And you should be able to read those right on your phone. See if that's working. Don't worry if you're overwhelmed. I did not do well on this quiz the first time I took it. Getting close, about 5 seconds. And then it'll tell us the correct answer. Time's up. And okay. 14 of you got it right in that situation. And I don't know what's more shocking about the 2 truths there. One, that 80% of the world's wastewater is discharged directly into the waters. That's a huge amount of wastewater. So that was shocking the first time I heard that. Or this other one, that a lot of the chemicals and the contaminants that go into the wastewater are actually not extracted as we go in there. And let's talk about what is contained in sewage. It's way more than just poop and pee in those environments. And I like to call them the 3 Ps. So even the best wastewater treatment plants can't pull the 3 Ps out of there. Personal care products, pathogens. One of the reasons we can actually measure COVID in the sewage to look at its concentrations and predict concentration in the cities, and pharmaceuticals. So we're talking about endocrine disruptors, all the medical drugs that we're taking, they're being flushed down the toilet. Those are accumulating in the poop and pee. They are not extracted, and they're going out into the water system, and they're bathing the organisms that are in those environments, and they're absorbing those as we go out into those in those environments. It's very difficult to pull that out. So why is that happening? Well, you might be thinking there's just not enough money to solve that issue, and it's a lower income problem. But that's not just the case. It's actually happening here in Los Angeles. It's happening in my hometown of Beaufort, North Carolina. It's happening all over the world. So let's learn a little bit more about the sanitation crisis and see, through understanding of that, if that gives us an opportunity to address it. So here's the second quiz. And again, it will show up. Okay. And you have 30 seconds. Okay. So we're learning about the extent. 3 different statements. Again, which one is the lie? Which one is incorrect in those choices there? This is a little bit harder, I found. I think I'm going to use this. 3, 2, 1. Okay, pretty good. That is the lie in the middle. 2 billion people live without safe sanitation globally. It's actually way more than that. It is a low ball, and it's one of the ones that statistics I found out 3 years ago that just completely overwhelmed me. And these are some of the statistics that are real. There's 2.5 billion people in the world that don't use the toilet, and that's open defecation. There's another 2 billion people that don't have access to safe sanitation. That is sanitation in which the waste products are actually contained and then would go directly into a sewage treatment. So that's 4.5 billion people in those environments. And who is most affected? Well, women can be the most impacted, not because of the general health issue, just because of the general health issues, but also because not having access to a closed toilet increases the chance of assault, and it also keeps them from going to educational systems. And the most vulnerable of all in these populations are the children who have weaker immune systems and are exposed to those pathogens. Over 1 million children die per year because of exposure to the sewage and the diarrheal diseases in those environments. So it's a massive problem in these systems. And some of the people, if you think about it right now, what is going on? What is going on in those systems, in those countries that are lucky enough to be living with toilets and wastewater treatment? Is it a contained problem? Is it under control? Well, we'll go back to the quiz and see what we can learn some from the facts. Okay, here we go. We're doing pretty well so far. You guys are, okay, here it is. Pick the lie on that one. So this is more about high-income countries and learning whether or not the sewage pollution is a problem that is just for some or for all. It's a big backlog right there, if it's true. 27 billion gallons. Okay, 5 seconds. Okay, really well. Everybody's doing really well with that. And you see these big numbers right here. And if there's anything you want to take away from this, the 4.5 billion, okay, that's primarily in the lower income countries. But this is not just a low income country problem. It's happening in the highest income countries. And here in the United States, it's a massive problem. That's a big price tag for infrastructure. $271 billion is needed to upgrade our systems. There's over 1 million miles of pipes in sewage systems that are in very poor condition and leaking. And in fact, they leak 1.2 trillion gallons of waste, this is just in the United States, into our water systems each year. That's a lot of gallons. That's equivalent to 1.8 million Olympic-sized swimming pools. So it's really a massive amount that's going on there. It's something that is just, it's going into the waters, and it's everyone's problem, and it's everywhere. Now, you remember from the first quiz, one of the facts we learned was that 80% of the global wastewater is discharged into the environment untreated. So we do that calculation I was just doing. That's 60 trillion gallons of raw untreated sewage enters oceans annually. This is a massive amount of pollution that's coming into these coastal zones and these environments. And so what is the effect on the oceans, these coastal systems, on their health? There must be something strong and impactful in these systems. So let's look at coral reef first. And the way we're going to do that, again, we'll use the quiz and test your knowledge about coral reefs. We're going to look at the impact of sewage on coral reef systems and review that. Okay, coral reefs. That's a high number, 96% with sewage pollution. You are allowed to talk to each other and confer with each other on this.
No, we're married.
That's fine. Oh, I know that even if you're not married. Okay, time's up. Good. This is a really learned crowd. Well, this is true. The coral reefs are very nutrient poor. In fact, one of the key ingredients for having a healthy coral reef is having pristine water. And what does that mean? Pristine, crystal clear water. That means low nutrients in those environments. And what's happening, one of the things that's happening because of the climate change and global warming and because of ocean pollution is that clear crystal water is going away. It's becoming more acidic, it's warming up, and it's filling up with pollution, which then clogs up the coral reef system. And let's dive into that to sort of understand that. Let's first look at the relationship between ocean pollution and disease in the system. And many of you know, if you've read about coral reefs, they're being hit by disease all over the world. And there is some suggestion that disease outbreaks are increasing with increasing sewage pollution. But it's been really difficult to tease that out in a rigorous scientific way. Well, 10 years ago, Dr. Becky Baker-Thurber, professor at Oregon State University, did just an outstanding study. And she found a very strong, non-debatable linkage here. And it is in this particular system, this is elkhorn coral. This was the dominant coral throughout the Caribbean that created the foundation in these systems. And this particular colony is being attacked by white pox. It's a white pox disease. It wiped out a lot of the corals in the 1970s. And what she found was that white pox was much more prevalent when the sewage pollution was leaking onto these reefs. And indeed, she found that an opportunistic pathogen, a human pathogen, was the cause of white pox disease in corals. She experimentally demonstrated this. So she showed that a pathogen that gets to these reefs in the sewage, that attacks a terrestrial mammal, can also attack a marine invertebrate. Pretty amazing to jump like that. So if this isn't a smoking gun, I don't know what is. And she has done subsequent work with sewage pollution showing that not just bringing the pathogens into the system, but the addition of nitrogen and phosphorus, the nutrient-rich enrichment of those waters, also increases pathogen growth on these corals. But it's not just disease that ocean pollution generates in corals. It really affects everything. Because remember, there's much more in sewage than just poop and pee. It's all those other, there's microplastics, the drugs, the endocrine disruptors, the hormones, heavy metals, all that is going into the coastal system. And if Stephanie did an amazing review of this, and what she found is that it affects corals at individual level, at the population level, and at the community level. And at the individual level, a little polyp, it's harder for them to breathe when there's sewage pollution around. It's always suppressing them. And it's harder for their symbiotic algae to photosynthesize and make sugars. It's harder for them to make a skeleton. And to add insult to injury, they have lower sperm count and smaller eggs, so a lower reproductive success. And this translates up to the whole community. So the population growth is slower over time. There's fewer corals showing up. And so the corals aren't proliferating as much. At the same time, there's more nutrients in the water. And that fuels algal growth, which is the nemesis for these corals, and they get overgrown in that system. So clearly they're getting hit, and they're getting hit hard. If there's one thing you know in marine systems is that coral reefs tend to be, we think of them as more sensitive than other systems. So is ocean pollution just hitting corals, or are other systems susceptible to that? Let's look at coastal wetlands and whether or not they're potentially being affected by sewage pollution. So here's another quiz as we transition into salt marshes and mangroves to learn about their interaction with sewage pollution. Okay. I would have got this wrong 6 years ago. It's completely changed in the field. Okay, almost time to check your knowledge. This crew is doing really well. The lie is applying directly. That's right. That's another high score for this. This class is going to get an A at the end of this. It's fantastic. So one of the things about coastal wetlands is that contrary to theory, or what a lot of people believe, is they, like coral reefs, they need really great water quality. And sewage pollution has a dramatic negative impact on their ability to resist climate change and to keep on providing the important services we need them to provide, like carbon sequestration, protecting our shorelines from waves, and also from generating important fisheries. And let me explain, okay? These plant systems are limited by not getting enough nitrogen and phosphorus. And so the thought had always been, if you had sewage pollution there that has a lot of nitrogen and phosphorus, the A&D will take it up and they will grow better. And you can see that in fertilization studies. On the small, but what happened at the small scale did not translate to what actually happened at the large scale. The marshes that are experiencing high levels of sewage pollution, and it's 30% of the marshes in the world, you actually see more luxuriant grasses. They get greener. They're more robust. They take up the nutrients. But they do something unexpected, and that is they take most of their tissue from in their roots and they put it into their shoots. They start competing for light, and they literally lose their grip on the soil. And you combine that with the increasing level of sea level rise and storm action that is happening, is that you get a collapse of salt marshes on their edges, and they're hemorrhaging carbon right here. This is 500 years of carbon that's just falling right into the sea. And sewage pollution is doing that indirectly. And of course, that's affecting the services. But what about, we just found this out 5 years ago. And we're just finding out similar things happening in mangrove, a little bit different mechanism. So what's happening in mangroves, again, we thought that we could use these systems to help us buffer against sewage pollution, but they're highly vulnerable. And what we found is that mangroves that have higher amounts of sewage pollution over years are more susceptible to dying off from droughts, for instance, in Australia. And again, what has happened, they shift most of their mass from the roots to the shoots, and they have roots that aren't as deeper. And those roots are really important for those trees during drought conditions so they can get the resources they need. So they don't have that stability anymore. They have weakened root systems, and when you hit them with the drought, they experience massive die-off in those systems. Now, one thing that's happening, it's not just these habitats can decline when they're hit with sewage pollution, they're more susceptible to climate change. They, like I said before, provide important services, one of those being fisheries. So, is there an indirect or a direct effect of sewage pollution on fisheries? Again, let's go back to our quiz. Let's see, okay, here we go. Test your understanding of fisheries. Okay. I've seen a couple of those happen before. That's a good place to snorkel is on an outfall sometimes. A lot of fish around it. Three, two. Very good, very good. So again, everybody's scoring really well on this. And one of the interesting things about fisheries is that like coastal wetlands, we had the prediction wrong. So fisheries are vital for communities all around the world. There's community-based fisheries, there are industrial scale fisheries, but billions of people get their primary source of protein from fish. And maintaining these resources in a sustainable way so that they're predictable and can be used by these human populations is critically important. And what we thought was that in general, we didn't have to worry about overpollution as a threat to fisheries. It was mostly overfishing or loss of habitat. And we're quickly finding out that that's not the case. And this is an emerging field of research, that pollution can affect juveniles, the larvae, then juveniles and the adults. It can affect their life history stages. It can affect their growth, affect their ability to feed. So it's having effects. And we're looking at whether or not that scales up to populations. And this will give you some examples. Those fish that are swimming through pollution, we always thought that they could avoid the pollution. But now that we understand the scale of coastal pollution, sewage pollution in these nearshore environments, we're finding the fish just can't escape being bathed in this pollution in many cases. Puget Sound, the coast of North Carolina, and these cities. And what is happening in the Chesapeake Bay, we see increased organ tissue deformities, tumors, gill damage. It's affecting their ability to respire, osmoregulation, and we're looking into the effects on reduced species richness and abundance. So fisheries, just like coastal wetlands, are not immune from pollution effects in these environments. We thought that was the case 5 to 6 years ago. We know it's not the case in these environments. So let's switch from doom and gloom and talk about solutions. And we have some good news here, and this is what I'm excited about. Let's see, we'll switch it. All correct. Okay. I know I always have to say, pick the lie again. Oh, it was close. Still got it right. I think this crowd got everything right on it. Yeah, that's right. So this is half right. Resource recovery from human waste, it does exist. And it has already been implemented. It's happening at small, medium, and large scales. It's just something we don't talk about very much in those environments. So I want to talk about some of these solutions. I want to talk about some of the untapped value that we're missing by not doing resource recovery in these environments and thinking about using poop and pee as a resource. We need to change the conversation, change that taboo about poo and peep, and this thinking about solutions and the benefits that can come to nature as well as the economy by changing the way that we process this waste. I think one of the most amazing facts that you see right here of the potential value in recycling poop and pee is that reclaiming wastewater is half the cost of desalinating water. And we know that the desalination plants are increasing right now because there's a global water crisis, and many places are heavily hit. But this is an alternative, less expensive way, water reclamation through sewage treatment plants that we're just not exploring. And there's huge values in, for instance, the gas that's generated from the accumulation of poop and pee, mostly in methane gas. And that biogas is a clean burning fuel that can be used, and it's worth a lot of money. So this is an economic incentive to explore these options. And here's an example of a system, relatively small in this scale, but it converts dirty water into drinking water. And this right here may be something that would be used at a small community. And it was originally called, you might have heard of this, toilet to tap. Not that appealing, doesn't sound that tasty. This may not have generated excitement about grabbing that glass of water at the end of that machine. So the marketing wasn't really there, but the technology was. And importantly, it's been used at small local levels, city levels, and at the country level. For instance, the country of Singapore, I believe, well, I know they use this, and I think 30% of the water is reclaimed. They want to get to 100%. And it's used here in California, in Orange and LA counties. And so it's a technology that can be used at much larger scales, but we're just not doing it. And it's important to realize that it's not just something you can use in drought-stricken areas where you're water limited. We now think about what's happening over the last 3 or 4 years. In North Carolina, Southeast, where it's typically been wet, we don't use water for agriculture. We're starting to have to do that because we're getting intense droughts, unpredictable intense droughts. We need to reclaim this water. There's a huge amount of it to help us deal with the massive variation in water that's happening with the changing climate in these environments. So it's a lost opportunity, but it's something we have the technology to gain. And here's one of my favorite ones. This is a toilet that generates electricity. And I love the idea of going to the loo and reducing your fossil fuel needs and your footprint in this environment. And it's I don't exactly know how it works. The point is that the technology and the solution exist to be able to do that, to be able to generate electricity by going to the loo. And this is another one. This is a small scale, but this is hopeful, and it has been scaled up a little bit. This is the generation of biogas from a small toilet system here. And that biogas is primarily methane, and that methane can then be used, for instance, for cooking in those environments. And it's highly valuable, and it just needs to be harvested from the accumulation of human waste practices in those environments. And another one, many of you have seen this before, are constructed wetlands. They're used across highways as filters, strategically placed as filters that will clean water that's running off from land or streets before it goes into the river. We can do the same thing with sewage sludge, for instance. Now, these are constructed wetlands, and so we control water availability, and they're not going to be as impacted by climate change like the natural marshes and mangroves. And what's really nice about these particular systems is they can be used in conjunction together. It's not just one. It's using multiple nature-based solutions, okay, with these alternative strategies to deal with the processing of waste in a much more efficient manner, to not only be better at cleaning the water, but to create resources for people, to create energy, to create water. And in this case, it creates habitat. I've actually gone into these constructed wetlands. There can be biodiversity hotspots. Birds and insects do really well in those environments. So I want to next talk about the Ocean Sewage Alliance. And the Ocean Sewage Alliance just put together a toolkit to talk about not only that these solutions exist, but how you configure and put those together to solve a problem in a certain locale. And the Ocean Sewage Alliance started a very short time ago in June of last year. And It's a conglomeration, and it's affiliation of people that are really interested in improving the environment and improving the health of people. And this started, and it's really more than an alliance or a partnership, it's an organization. And Stephanie started this, and it has grown immensely over a short 1-year period of time. And it really started, the work I presented here is the direct result of her dissertation and her work, where she discovered that ocean sewage pollution was just not an isolating stress factor. It was widespread. It wasn't that 9% of the corals were exposed to it. It was that 90% of the corals. It's not 3% of the marshes, but 30%. And it has dramatic impacts on ecosystems, on individuals and populations. But she also found, in discussing this with her colleagues and everybody else, there's tremendous taboo around talking about poo. It was awkward conversations. How do you get people? But you can't solve a problem if you don't start talking about it. So she needed to do that. And she, unlike most academics, when they point out that this is wrong, and that's 90% of their talk, then they leave it there and they don't do anything about it. She said, we need a solution. We need to come together. She said, let's build an alliance. And she started calling people, and it's a really interesting story because she called policymakers. She talked to resource managers. She talked to sewage treatment plant managers, talking about their groups, and they get together, and they said, not many big conservation organizations have reached out to us. This is great to hear that. Let's get everybody together. So she brought everybody together. They were brainstorming for a while, and they've come up with a big list of things that they're going to tackle over the next years. And one of their mission is not just reducing coastal pollution, but they wanted to do something that would really catch people's ideas. And this is just a great mission. I love it. They want to re-potty train the entire world. A lot of groups are focused on trying to reduce coastal pollution. But they changed that. It's a marketing. They want to say, we want to engage people to talk about poop and pee. We want to make the invisible visible. Here's this big problem. We don't want to make it. There's a resource potential here. There's energy here. There's economic opportunity. Let's talk about that. And then only through talking about it can we bring up the solutions. So they brought the alliance together. They came up with that sexually named group, Ocean Sewage Alliance. They got the cool symbol on there. And they started thinking about marketing in a different way. And here is one of their first marketing videos. Could you play that back there, please? Okay, here.
Nothing satisfies quite like fresh pea. Crisp, yet complex. This aqueous marvel can quench your thirst in infinite ways. Once your liquid gold is refined, you can use it to bathe, water plants, and make any drink you want. Like a cool glass of lemonade on a summer's day. Refreshing, satisfying, and so very, very hydrating. You deserve the best your urine can offer. So don't let it go to waste. Because pee's not waste at all. It can be clean water.
Isn't that great? I love that octopus, and I love that. Now, let me see if I get that's not moving to the next one. Well, certainly when you first see that, it really hasn't stimulated somebody to immediately say, pour me a glass of recycled water. But it does get them to start talking about the issue of recycling water, of recovering all the water that's in the sewage treatment plant. That sounds like it's possible. Most people don't even know it's possible. So it's important to have these new marketing outreach strategies that bring people together. And it's only by bringing people together that we can overcome this stressor that we have the solutions to do. It just seems silly that we're polluting our environment so close to us and the animals and plants that we care about in such a massive way, and we have the ability to stop that. And so this needs to bring this conversation forward. Could you help forwarding that by chance? To the next one? Okay, great. So one of the things she's doing is saying, let's think cross-sector. I want human global health with the Nature Conservancy. The Nature Conservancy worked with the Gates Foundations. Conservation International, Duke Restore. she was so excited when she got Earth Justice signed on. And I remember us being in the living room. She said, Brian, you need to join this too. I'm like, what do you mean? It's not really with what I do with marine ecology. She says, Duke Restore, Duke Wetlands Center. This needs to be front and center. I said, you're absolutely right. We need to be involved with this. How do we restore ecosystems to help reduce the ocean sewage pollution problem? So I'm proud to be a part of this, and I'm also thrilled to announce that the Aquarium, well, this has already been announced, but the Aquarium of the Pacific is also a founding partner with the Ocean Sewage Alliance. It will be a part of this. Now, what can you do? This is always a big question. The most important thing you can do right now is start to talk about it, to get rid of the taboo of poo, and start to ask questions. In your area, in your house, how is waste processed? Is it in a septic tank? Is that septic tank working? Is it the best one that can be used? Is there a wastewater treatment plant that's nearby? Do they recover all the water, or could they? Are there opportunities? Get involved, find out where the waste is going and where it's ending up. I did this in Beaufort, in North Carolina, where I am. I was astonished. There was a pipe every 100 feet along the creek that I love, and then every time a storm comes, it takes all the sewage from the 5,000 people in the small town and dumps it right into that creek for 5 days straight. Untreated. And I was just oblivious walking around with those pipes. So get involved there. And there's a lot of other things you can do. We've heard many of these before. Only flush the 3 Ps, paper, poo, and pee. No medicines, nothing else should go down the toilet. Maintain your stormwater system, your gutters, and your septic systems to also prevent other things from going down. Begin to talk. Reach out to your local reps. Once you find out about that, talk to them about wastewater treatment in your area. What can be done to improve that? To include and improve the quality of water in the environment to help people and nature. Vote for policies to improve water infrastructure and donate to programs working with safe sanitation. So if you want to find out more, you can go to oceansewagealliance.org, and there's all kinds of these interesting films that they're putting together on there and opportunities for you to get involved. And then the last, this is not a quiz. By the way, everybody passed. This is now, having heard the presentation, submit one word that sums up your feelings about sewage pollution. And then we'll see that result there. So just put one word in there. Please. Yikes. Crap. Wow. Look at that. That must be Peter up there, the misspelling possibilities. PK. Well, this is kind of interesting. I've never done this before. But you see some of that being overwhelmed. This is a very serious threat. But also there's solutions and hopefulness that we can come together to address this. So hopefully you feel like I do, in that you're kind of astonished you didn't know this was going on at all, and it's all around you. But there's opportunities to come together across sectors to address this, and the solutions do exist. And we can help people and nature in a major way. So thank you very much. Mm-hmm.
You talked about methane gas, and maybe I'm wrong, but I thought methane gas was hard on the ozone layer.
It is. It's much harder than, yeah, it's one of the worst ones. And it's, well, that's a good point. If it's burned, it releases CO2. It's an oxidized form of methane. So methane's produced when bacteria are breaking down poop and pee without oxygen. It's released a lot, like in freshwater wetlands, the methane comes up. If you capture that and burn it, it releases CO2, so you're actually exchanging one greenhouse gas for the other, but I forgot the potency, but methane's 10 to 50 times more potent. More effective at insulating. So it's a better exchange. Yeah. And there's also the extraction that you have to look at the opportunity cost. If you're using that, what are you not using and how much you're producing? But you're exactly right. You need to think about that. Oh, and then,
What an absolutely phenomenal presentation you had this evening. I wanted to find out, has there been any studying on encouraging people to have plant-based diets? Also, I saw something that had to do with limestone. It's supposed to help with the water. And in terms of medication, I don't think it's going to be 100% to be able to avoid medicine in the water, because when people have medications under treatments, I'm thinking particularly about like cancer type drugs like methotrexate and cytoxin. What's your thoughts on that with that type of medicine pollution into the water? And I gave you a 3 loaded question.
that's right.
But
Well, I'm trying to go over the 3. I'm always,
Okay.
First one, plant-based diets. How could they help with that? I'm not so sure thinking about the sewage pollution. I have not looked into that, so I don't know the answer to that. The quality, how does that change? I'm not so sure. That's an interesting question. Yeah, I think it should be, certainly I study the organisms and it changes the quality of the poop all the time, whether a sea otter eats an urchin or something else and changes those. Thinking about limestone, and you're thinking about limestone and the treatment of water.
It's supposed to help with the treatment of water, so would that help just putting in different places? Would it help putting it different places with a really high level of pollution in the water?
The limestone help can buffer the pH, so
Right.
if the pH is changing, so you could
Have they
use it
considered
strategically.
doing that and putting it different places actually and setting it down?
I'm not so sure if that's been used in that situation. I know it counters acidification, so like streams can be used, but that's an excellent point. And the third one was about the medicines. How do we
Medicine.
reduce the amount of medicines in there?
Right. And
And
this-
proper disposal is one of the most important ones that we need to have available, like in drugstores, and signs up, like we do with light bulbs or anything else. Please recycle your medicines here or dispose of your medicines here.
And the risk of the medications is because a lot of the corals they use to make medications. So what's the danger of the medications affecting the coral to reduce the quality of the medications that's coming from the corals?
Yeah, so the corals are a medicine chest in many ways, and so a lot of these, a lot of drugs that have helped humans have come from natural-based chemistry on coral reefs, and so that needs to continue, and that's more difficult if those systems are degraded. The corals are being hit by a lot of different things. I mean, fish larvae, for instance, Puget Sound, find caffeine and nicotine and some illegal drugs that are actually in the tissues of those animals. So it's just anything that goes down the toilet can be absorbed. So it's not just the ones that were derived from the corals. But thank you. Those are interesting questions. I think did you have a question?
I'll shout.
Okay. I'll come closer.
All right. The algae bloom that we experience in the ocean,
Yes.
that basically chokes off everything once it gets there because it depletes the oxygen and other things. But is that caused also by the sewage problem?
It's caused by an increasing amount of nutrients, and that what we thought it was before. There's a big paper coming out in PLOS One that shows that sewage contributes much more than we thought, like in these other situations. So in that particular, we get these blooms because of increasing nitrogen and phosphorus, which is coming from 2 things: runoff from non-point solutions from like farms and agricultural fields, as well as sewage pollution. And sewage pollution is doing a lot more than we ever suspected. We thought it was minimal. It may be up to as much as 40% of the nitrogen and phosphorus. And that generates those big blooms. It also generates the blooms that cause the red tides, not just the low oxygen. Those toxins can really affect humans and wildlife. So yeah, sewage does contribute in a major way to that. Yeah. I didn't think so 5 years ago. No, I mean, this is really changing the way marine biologists think about sewage as not being just isolated.
How effective is the Long Beach, LA area in addressing these issues?
I don't have the knowledge on that. But I mean, I think that's a great way to start the conversation. Wouldn't it be interesting to bring somebody in to have that discussion who knows that? And you could say, what happens during a storm, for instance? Or at what point, what's the volume that you can handle before you just jettison that sewage, and where does it go? As soon as I found that out about Beaufort, I went in and talked to the mayor, talked to local politicians, and I said, these are waters I like to use. I'm worried about my children and my friends' children and ourselves. So it's a great question to start the conversation.
Brian? So I know when Steph started this, the whole resource idea was pretty important. Have any investors picked up on it? I mean, has it gotten, because there's so many investors these days that want to both make money and, save the world. But has anybody picked up on this to try to make money off it?
I was thinking about that today. I don't know the answer to it. And I wanted to know today. I'm like, okay, I'm going over the solutions. They just sound so great. Is there incentive to do this? In Singapore, I know that it was mandated that this is we're gonna hit these levels of resource recovery in water. And so if that's what it has to be, say for instance, they're all electric cars and this is mandated, then I think there's an economic incentive to join that. So it's an economic question that I think needs to be addressed. Because if the solutions are there and they're not upgraded and they're not scaled up, big enough scale, is there an economic limitation? Yeah.
So referring to the toilet to tap water project thing, what's the difference between that water and the water that, sometimes I see like on like flower fields or, gardens or whatever, they have signs that say reclaimed water, not safe to drink or don't drink. So what's the difference between that type of like reclaimed water and
fully recovered, drinkable water? Yeah, gray water.
And if it's not safe for us to drink, how like safe is it for like the plants and the earth to be soaking and drinking that water?
Right. So there's a huge difference in those two, reclaimed water or gray water and this drinkable water. And there's not much variation in the quality of the drinkable water. It has to meet really high quality standards. And so in Singapore, I have colleagues there, 30% of the water is like that. And he's like, yes, we just drink it and it's clean. For reclaimed water, there's a lot of variation in that. And the warnings are it could, for instance, it not be fully treated or treated at all. It's reclaimed in sort of runoff water that's brought into a certain area. And that can have a high amount of nutrients, potential pathogens, and those things may not negatively affect plants in those areas. So the variation in gray water, reclaimed water is pretty high. So it's a good idea, definitely not drinking that. But this other water is really clear, and I did once I heard about this, I did the research and went right to Singapore. And that's where it's happening, 30%. It's pretty amazing. I had the same question. Okay.
Can you make that high quality water from the water that's like not good for plants to soak up?
Could you repeat that again?
Can you make that high quality water? Like
from the really dirty water?
Yes.
Yes, they can. I was just amazed that they could. It's fully drinkable water after it goes through that process, fully clean. It's not just clean enough to put back in the environment. So a lot of the wastewater, we don't do that in most places. It's cleaned and we take out as much of the nitrogen and phosphorus that we can through settlement and some treatment, and then we discharge it back into the rivers. That doesn't go to our faucet. It'd have to go through a lot more treatment. Great question.
Hi. So I work in the construction industry, and I'm wondering, is your alliance going to target, like, I assume you're going to work with municipalities and try to get into that avenue. Are you working towards kind of the construction industry and reforming how we design things?
I don't know, and I think it's a great idea. I'm writing this down in my head right now to talk to Stephanie.
Yeah, I
Because
don't know if
right,
that's
it's
the
new
goal.
construction, new houses.
Yeah.
How do we get these new
and-
innovative toilets?
Well, Public Works too, in particular,
Works,
is what
right.
I was, yeah.
Public Works is very engaged.
Yeah, and she is working with many of the
Okay,
public
cool.
works. But private industry is
Yeah.
very important to engage because there's innovation going on there. There's a big, largest part of the market in many ways. And
Yeah.
so that collaboration needs to be there.
Yeah, I'd love to know.
Great suggestion, thanks.
Yeah. This thing's only about 5 months old in terms
Yeah.
of being officially announced, so it's brand new.
Yeah. Please reach out, send that email.
The children are our future, the young people. So is this going to be taken to the school system to try to reach out to the children to get them involved since they're so young? And they're also very powerful because if you look at what they're doing in terms of climate change, has this been considered? Because I think it would be absolutely phenomenal to get them involved.
I think I'm going to write that down as well.
Part of what you're going to be doing, or you
Involving-
already started?
I'm not sure that's been in discussions, but it's a great suggestion. And I think involving younger generations, children, and I'm doing this now with the undergraduates at Duke, talking about this. This was never a part of the lectures in marine ecology and conservation. And now I have a whole lecture on this. So it needs to be done. These are the people, the change makers of the future. So we need to talk to them about that and the opportunities.
We want to wrap it up now, but we're going to adjourn to outdoors for drinks and conversation. And I think, Adina, you have some sort of special.
I do. We have an outhouse cafe. And we have some really fun surprises to continue the discussion.
Okay.
And I just want to say, I know Frances, and she'll probably take this to City Council on Tuesday night. So.
Oh, fantastic. With that question that you had, what happens here at Long Beach?
Thanks a lot, Brian.
Yeah, thanks. Thanks so much.
You're almost as good as Scott.